US Physics Olympiad, year 2013, USAPHO. Semifinal exam. Problem A3. A beam of muons is maintained in a circular orbit by a uniform magnetic field. Neglect energy loss due to electromagnetic radiation. The mass of the muon is equal to 1.88 10 power negative 28 kilograms. Its charge is negative 1.602 10 power negative 19 coulomb, and its half-life is 1.523 microseconds. Questions. Question A. The speed of the muons is much less than the speed of light. It is found that half of the muons decay during each full orbit. What is the magnitude of the magnetic field? Question B. The experiment is repeated with the same magnetic field, but the speed of the muons is increased. It is no longer much less than the speed of light. Does the fraction of muons which decay during each full orbit increase, decrease, or stay the same? The following facts about special relativity may be useful. First, the Lorentz factor for a particle moving at a speed v is gamma equal this expression. The Lorentz factor gives the magnitude of time dilation, that is, a clock moving at a speed v in a given reference frame runs slow by a factor gamma in that frame. The momentum of a particle is given by E as a vector equal gamma m v as a vector, where m does not depend on v. The Lorentz force law in the form dp over dt as a vector equal q multiplied by E electric field plus cross product of v and the magnetic field B continues to hold. Solution. Question A. Let's count what is the force and what is the radius of orbit of this muons due to force from magnetic field. We have centripetal force mv square over r equal force from magnetic field, which is qvb. And also we can write the formula that the total distance to orbit equal to speed multiplied by period. Now we can put radius, which is vt over 2 pi, and put it in this formula. From here we can find what is the period. Period equal 2 pi m over qb, so it does not depend from velocity. And this period equal to half-life time tau. So from here we can count what is a magnetic field in this case. Magnetic field equal 2 pi m over q tau. When we put numbers we will get 4.84 millitesla. That's the answer for question A. In case of relativity, we can still use Lorentz formula for change of momentum, but momentum now equal gamma mv, and the radius still equal to vt over 2 pi. From this formula we can find that period equal previous period multiplied by gamma. But in a frame of reference of muons, which moves with a very high speed v, we have a time dilation with a factor gamma. It means that half period will increase on this factor, and again this time will be the period of rotation. So it means that this time will be half a period in a frame of reference of this muons. So it means that the answer for a question will not change. It means that half period will increase for the same factor, and we still have same fraction of muons decay during this period of rotation.